So in existing hash map, you know about that. Get is a method. If you pass a key here, you will get the value out of from this map. And if you want to add that method, you will use put method to add this key plus value. So this is the way where we are calling that method. And internals of a hash map, it look like that key based upon key hash code method get called, and this like hash code method calls this like as a structure like upper list, and in that list this is your hash code of a key. Okay, hash of a key, and here that key value are getting stored. This kind of a linked list are internals. Okay, so I am just clearing the basics, so you will get more details about the concurrent hash map. So internally hash map look like this. Okay, so why concurrent hash map came into picture? So all the operations need to become a thread step. This is the requirement. That's why concurrent hash map came into picture. And whenever we require the retry operations, not is entirely locking. Currently, if you need to put method, call that pull method, hold this map object getting locked. Okay, this map object getting locked. So avoid that locking full object, that the concurrent hash map came into picture. Okay, that's the basic about the means hash map, and why concurrent hash map came into picture, means why this is required to build that. So class level, if you check that, map is a parent thing. Concurrent map is built upon map, and concurrent navigable map and concurrent hash map, it's a build on top of the concurrent map. Okay, concurrent hash map is the implement also serializable, which is a marker interface. Okay, by combining the concurrent map, navigable map and serializable, that concurrent hash map getting built. Okay, we'll talk more with the example, like if you want to create, how you can create like concurrent hash map. You will create a map and concurrent hash map. It's a simple thing, or it's the same thing which you are doing put operation, like map.put. And if you want get here full map, you can put, or you can call simply like map.get, like map whatever object is your here map, we are calling get with the AAA because this is the key. But what's getting changed? Okay, so whenever we are, suppose this is your the hash table, or we are saying where we are storing all hash codes and the mapping. Okay, hash codes, like these are the hash code based upon key calculating, and this is the list. So currently with the normal hash code, whenever get method call, nothing is locked. Same happen with the concurrent hash map. Whenever get method call, no locking here required, and in a concurrent map also no locking is required. But while a put, if you are doing with the normal map, then what happen? Whole the object getting locked, because we are updating the data from one because if you want to add one element here, then whole the lock is required in a map. Okay, but in a concurrent hash map, this is only getting locked, because he know that if you are adding the node in this list, why we are locked these three hash buckets. Okay, in a concurrent hash map, only this bucket getting locked, other are open to read and write. That's the main advantages here we are getting in a concurrent hash map. We are locking at a bucket level, not a whole object getting locked. So that is the main difference between map and a concurrent hash map. Okay, in example here also, this is a very clear diagram, like concurrent hash map segment here, like 0 1 2 3 are segment, and based upon this hash code is calculated. Suppose here at a 1th place key is a 21, value is 12, and next element is this, and next element this. Similar way for 2, this is and this is. If there is a no element, then null is added at here. If no particular key is mapped with that hash code, then it's also null. But suppose you are adding one element in this segment, that time in a concurrent hash map, this segment only get blocked. This is open for read write, this is also open for read write, and this is also open for read write. Okay, but in a hash map, this is a concurrent hash map, this is locked. But in a concurrent hash map, whole object getting locked. Okay, whole object is locked. Here read write open, read write open, read write open. This is only locked because we are adding element here. Okay, this is the pictorial example. So takeaway for today's session, why we use the concurrent hash map. Okay, concurrent hash map over the map. Okay, why we use that? Firstly, it's provide 100% safety, like a hash table. Dividing a segment, like earlier also we discussed, dividing a segment portion and allowing the parallel access, because one bucket is getting locked, other bucket are open for read write. Locking at much as a finer granular level, like a bucket level locking, we did just discuss. High concurrency, multiple thread can access that data. It's 100% thread first. Write is done, lock on a segment at a bucket level, locking is there. No locking at a object level, and if multiple objects are trying to modify that data, then concurrent modification exception are there. So exception and everything are handled in a concurrent hash map. That's why we are recommending to, if you have real use case, then go with the concurrent hash map, which is a more tuned data structure in earlier Java versions. Okay, yeah, that's it. If you have more questions about the internals or internal code, how it's getting handled, will let us know. We'll create a session on that. Yeah, thank you all.